Welcome to this lecture of our course, Key Technologies in Generative AI. In this session, we will delve into the key technologies that enable generative AI, such as neural networks, generative adversarial networks (GANs), and variational autoencoders or VAEs. Understanding these technologies is essential to grasp how generative AI models create new content. So generative AI is built on a foundation of advanced technologies. So we will explore the most important of these technologies and discuss how they work together to produce innovative AI applications we see today. Let's move. Introduction to neural networks. This is very important. So at the core of generative AI is the neural network, a model inspired by structure of human brain, what we see in the right side. So neural networks consist of layers of interconnected nodes or neurons that process data and learn patterns. These networks are the building blocks of more complex AI systems and are used for tasks ranging from image recognition to natural language processing. In a neural network, data is fed into the input layer and processed through hidden layers and outputted at predictions or classifications. So what we mentioned here, that they consist of interconnected layers of nodes that mimic the way the human brain processes information. Similar thing we see here. Next, very important is understanding GANs or generative adversarial networks. This is very important. So one of the most exciting technologies in generative AI is the generative adversarial network or GAN. A GAN consists of two neural networks, a generator and a discriminator that work together in a competitive process. So the generator creates new data such as images or text, while the discriminator evaluates the data and provides feedback to the generator over time. This feedback loop helps the generator produce increasingly realistic content. What we see here also. So feedback, so generator generates and discriminator gives the evaluates the data and provides the feedback. So GANs, so this is the total scenario what I explained. So GANs have been used to create everything from AI generated art to deepfake videos, demonstrating their powerful ability to generate high quality synthetic data, what we say here. The next important is exploring VAEs or variational autoencoders. So another important technology in generative AI is the variational autoencoder or VAE. VAEs are a type of neural network designed to generate new data that is similar to the input data. Unlike GANs, which focus on creating realistic outputs from computation, VAEs learn the underlying distribution of the data and generate new samples by sampling from distribution. VAEs are powerful, particularly useful for tasks like generating images, text, and other forms of complex data. They are often used in applications that require creation of new similar examples from a dataset, such as generating new model, new product designs, or synthesizing new data from training AI models. So what a sample diagram is illustrating here, the encoder, decoder, and the latest space. Next next important learning is the role of deep learning. So deep learning is a subset of machine learning, plays a crucial role in generative AI. It involves training large neural networks with many layers, hence the term deep learning. These layers allow the network to learn complex patterns and representations from large datasets. Deep learning is what enables AI models to perform tasks that were previously thought to be impossible, such as generating realistic human faces or composing music. The power of deep learning lies in its ability to process and learn from vast amounts of data, making it the driving force behind the success of generative AI. It's a diagram what we mentioned here. The next, training generative AI models. So training generative models like GANs and VAEs require large data sets. You see that and significant computational resources. The training process involves adjusting the model's parameters to minimize errors, and improve the quality of generated content. During training, the model learns to create output that are increasingly similar to target data. For example, in a GAN, the generator gets better at fooling like discriminator over time, resulting in more realistic images or text. This iterative training process is key to developing effective generative AI models. Next, application of key technologies. The technologies behind generative AI are applied across various industries. In marketing, generative AI creates personalized content and advertisements. In entertainment, it generates realistic visual effects and even entire movies. In healthcare, AI models generate synthetic medical data for research and training purposes. These applications showcase the versatility and power of generative AI technologies in solving complex problems and driving innovation. Challenges in generative AI technologies. So despite their potential, generative AI technologies also face challenges. The need for large data sets and high computational power can be a barrier to entry. Additionally, the potential for generating biased or unethical content requires careful consideration and mitigation strategies. Addressing these challenges is crucial for the responsible development and deployment of generative AI. As we continue to advance in this field, it's important to stay aware of these challenges and work toward solutions that ensure AI benefits everyone. Recap of key technologies. To recap, generative AI relies on technologies like neural networks, GANs, VAEs, and deep learning to create new content. These technologies are the backbone of modern AI systems, enabling the creation of everything from realistic images to synthetic data. Understanding these key technologies is essential for leveraging the full potential of generative AI in your organization. So in the next lecture, we will explore real-world applications of generative AI across different industries. We will see how these technologies are being used to drive innovation, improve efficiency, and create new opportunities in various sectors. So do you have any questions about the technology behind generative AI? Let's discuss how this technology can be applied. So looking forward to the next session where we will explore or deep dive into exciting real world application of these technologies. See you then. Thanks everyone.